Welcome back, my dear students. So, in today's class, we are going to discuss another important concept of PUC second year, that is dehydration of ethanol to ethene. This reaction is also called as acid catalyzed dehydration of ethanol to ethene, or generally speaking it can be also called as alcohol to alkene. Means we are going to remove water from alcohol and we are going to get alkene from that, and that will be catalyzed by an acid. By using H2SO4 as a dehydrating agent, we are using the reaction, and that's why it is called as acid catalyzed dehydration of ethanol to ethene. So this concept in Karnataka boards can be asked for 3-mark question. So one of the most important expected question for 3 marks for your board examination, this one. So let us begin the content, how it actually works. So ethanol is nothing but CH3 CH2OH. So when this ethanol is treated with, this is ethanol and concentrated H2SO4, specific about 443 Kelvin compulsorily, because at lower Kelvin or lower temperature, ethanol will have a chance of giving ether. It will not give an alkene. That's why at elevated temperature about 443 Kelvin, your carbon containing OH will be marked as alpha, the next carbon will be marked as beta. From alpha carbon atom OH and from beta carbon atom H, both will be removed as H2O. So correspondingly we are getting CH2, single bond will be converted into double bond and CH2. So this molecule we are calling it as ethene, or you can even call it as ethylene. So this reaction with the mechanism, it proceeds in 3 different steps. So when we go for a mechanism of this one, it is an acid catalyzed mechanism. That's why step number 1 we call it as protonation of alcohol. Protonation of alcohol, that is ethanol, you can say. Protonation means ethanol will abstract the proton. That proton comes from H2SO4 because it is acid catalyzed reaction. So elaborated structure of ethanol I am writing. Ethanol is CH3. See all 3 hydrogens at different ends of the carbon written, CH3 CH2, and it is OH. So oxygen, as usual, it will have a pair of electrons, 2 above and 2 below. It will abstract a proton, that is H plus. This H plus comes from an acid. Since the reaction proton abstraction is there, reaction quite faster it will be there. So immediately this electron will be making a bond with the hydrogen. Immediately oxygen will capture that proton, and thereby the CH3 on the left side and CH2 on the left side of those oxygen will remain same. So now oxygen eventually will be bonded to 2 hydrogens, and those 2 dots down as it is remain. Since oxygen, you can notice oxygen giving an electron to hydrogen, oxygen usually develops a positive charge. This we call it as a protonated alcohol, and the reaction is quite fastest because electron will be immediately capturing that H plus. That's why the reaction is quite fastest. Second step is said to be formation of carbocation. Formation of carbocation. So in this step what will happen is, to begin second step, in majority of the mechanism you can remember what you got in the first step. Now there same too you have to copy in the second step. Means I got this molecule in the first step, so same thing I have to copy here in the second step. So in the second step what will happen is, I will get CH3, CH2 and OH, and the dots as it is, and a positive charge here. So eventually what will happen is, this reaction is quite slowest. So the bond is going to break. The carbon oxygen bond is going to break heterolytically towards the carbon, so that whatever this molecule is there, this entire molecule will be eliminated as H2O. Hope you can notice that. The entire molecule will be eliminated as what? H2O. Then what is left? CH3, CH2, and since carbon is losing the electron, it will have a positive charge. Since second step is a very slow step, this step is a very important step and it is called as rate determining step. Entire mechanism depends on stability of carbocation formation. So when you go for the third step, in third step what will happen? There is a loss of a proton, loss of H plus to form product. So here what will happen is, the same carbocation will be stabilized by hyperconjugation effect. Means whatever the that water will be removed, and the carbocation I am using here in the third step, same carbocation which I have got above in the second step, I am using it in the third step. So here positive charge is there. So reversible arrow mark everywhere in the mechanism. So your carbon containing positive charge will be usually alpha, and the next carbon, this is alpha carbon, this is beta carbon. From beta carbon atom, one of the hydrogen, either 3 hydrogens are there, any of them can be lost. So hydrogen will be removed as H plus. So I am removing this hydrogen. This hydrogen will be lost as H plus. While going, this bond is conjugated here. So it means that carbon-carbon single bond will become carbon-carbon double bond. So it is called as a no bond resonance, or nothing but a hyperconjugation effect. So this is what our end product we got is ethene. I think easily you can notice here we have started from ethanol and eventually at the end we got ethene. So in the entire mechanism, it is catalyzed by an acid, that is H plus. So that's why it is said to be acid catalyzed dehydration of ethanol to ethene, which is very, very important 3-mark question. Hope you enjoyed it, students. Thank you very much.